We have already discussed about what is a pure substance and what is a phase. Now let us discuss about the change in properties of a pure substance when it is heated. For example, let us take a substance at normal temperature. Now, so this is a solid form. Now let us write this is in solid form. So suppose we are heating this at constant pressure. Okay. So we are doing this at constant pressure. Now once it is supplied, when you are heating it, it absorbs the heat and it will reach a state when it is about to change its phase, that is it is about to melt, that is getting converted to liquid. Okay, so we will call this process sensible heating. That means you are simply heating to raise its temperature. Okay, now it has become a solid, but it is about to melt. Okay, so what is the next stage? Right, next stage, it will be converted to liquid. So that means this is a phase change process. Okay, phase change process. So we will call this state as saturated solid. We will call it saturated solid. That means saturated means when it is about to change its phase. And now here it will become saturated liquid. Okay, so that means if you cool it, it will get converted back to solid. Now, so next stage, we are again supplying heat, we are again heating it. So what happens is that this liquid, that means its temperature will increase and it will reach a state, still it will be liquid itself. This is again sensible heating, because when we supply this heat, that heat will be used to increase the temperature of the substance. Okay, again this state is also a saturated liquid, that is with respect to vaporization. So this is also saturated liquid, this is also saturated liquid with respect to that particular phase change process. So this is with respect to that melting, and this is with respect to that vaporization. So now when you supply heat further, so if you further heat, this liquid will be converted to vapor. Okay, now its phase changes. So this is a phase change process. So this is a phase change process, and now its state is saturated vapor. Okay, this is called saturated vapor. Now if you supply heat further, the temperature of this vapor increases, and again this is in the gaseous form or the vapor form. This is, we will call this superheated vapor. This is called superheated vapor. This process is sensible heating. Okay, that means you are heating to increase the temperature and there is no phase change associated with it. Okay, so to make some terms clear, during the phase change process, when you supply heat, we will call it latent heat. Okay, we will call this latent heat. Right. Okay. So, so in the subsequent lectures, we will study about various diagrams representing the change in properties of the substance during these processes. For example, for this process, we are doing this for a particular pressure. For example, let us take the example of water here. So water if you heat water at 1 atmospheric pressure, let us take the ice initially. So this is the solid form, that is the ice. Let it be at minus 20 degrees Celsius. So if you heat it, it will reach 0 degrees Celsius ice. So it will still be ice, that is a saturated state. If you heat further, it is a phase change process and it will be converted to 0 degrees Celsius water. Okay, so this is a phase change process. Remember that we are heating this at constant pressure only. Again, if you heat it, it will be converted to 0 degrees Celsius to 100 degrees Celsius. Still it will be water. It is called saturated liquid state. And if you supply heat further, this will be converted to vapor at 100 degrees Celsius. Okay, so that is a phase change process. And if you supply further heat, it will become, you can supply heat to raise its temperature, let it be up to 150 degrees Celsius, and this is called superheated vapor. Okay, so this is for water. This can happen, so you can repeat this experiment for any substance. Okay, water has a peculiar property which we will discuss, so its diagrams will be slightly different than other diagrams. Okay, one thing you need to keep in mind is that, so here during the phase change process you can see that temperature remains constant during phase change. So here also you can see the temperature remains constant. So this is called saturation temperature, right? So this will be, temperature will remain constant. Okay, so what are we going to discuss? We are going to discuss about the change in properties of these substances. So in this case you can see we are heating at constant pressure. So what happens to the specific volume, or 1 by density, or just be density, what happens to the density during this process? You can see that when you are heating it, the body expands, right? For a normal solid other than that of water, the specific volume keeps on increasing. You can see that throughout this process, specific volume, it keeps on increasing. So you can plot the diagram between pressure and enthalpy. That means we will repeat this experiment at different pressures. P1 is equal to C, P2 is equal to C, like that for different pressures, and we will note down the different specific volumes at each of these points. Then we will try to plot a diagram. Then you will get a PV diagram. So that shows the variation of pressure with respect to specific volume. Then similarly you can plot, see, you can find the variation of entropy. So what happens to the entropy during this process? In almost all solids, the entropy keeps on increasing when you heat it. When it gets more heated, the disorder will increase, so entropy will keep on increasing. You can plot the diagram between this entropy and the various pressures and temperature. So similarly we will plot the change in enthalpy during these processes. So what happens to the enthalpy? That means by plotting these various, we will get various diagrams like PV diagram. Okay, we will draw that. Then we have the commonly used diagrams are temperature entropy diagram, TS diagram. Then you have the HS diagram, or this is called Mollier chart. Okay, this is the chart available. This is a very useful chart to predict the properties of the substances. Then you have the TV diagram, temperature versus the specific volume. Okay, so these are the important charts which we will discuss in the subsequent lectures. First we will discuss about the PV diagram, pressure volume diagram.